Thank you very much. It's a pleasure to be here today and to be in my favorite city in the world. I have come to Graz since the late 90s, and I can say that even though I had dinner on Friday with Clint Eastwood at the next table, he was, really, I'm not making this up, and Clint Eastwood was still looking pretty good at 80-something. But I want to say that Monterey isn't all it's cracked out to be, as Mr. Nagel, whom I met in 2006, has shown. This is a city that's growing, while Monterey is not growing. So thank you, Mr. Drexler, for having so much faith. I haven't read the novels that you have read, so I'm very keen to now find the literature that you have read and therefore be able to learn something more about Monterey. But thank you very much. Thank you for your welcome. Thank you, Landesrat, Landeshauptmann, and Bürgermeister for all being here. I want to thank, most of all, I would like to thank Dr. Wolfgang Priebel, who has invited me to come here and speak today. Dr. Priebel and I go a long way back, and we've worked together in many different circumstances, and I want to thank him and the great work he's doing at JOANNEUM Research. This is something that you do so well. We have much to learn from you in terms of how you do your research and put together outstanding organizations. So I come here as much a student of what you do as trying to tell you a little bit about what we do. So my theme today is managing and leading in an exponential age. And I'm going to basically pick on three different themes to try to show that management as we know it today is going to completely change. So let me give you an overview as to what I'm going to do. I'm going to talk about the second machine age, which JOANNEUM Research represents through its GNR focus: genetics, nanotechnology, robotics, and of course digitization, which underlies all of it. This is changing everything we do. I'm going to talk about the three fundamental change drivers in the exponential age, which drive the change, and why this means so much for managing organizations in the world today. I'm also going to talk about managing and leading in this age, and then about leadership, learning, and working in such an exponential situation. And finally, I'm going to go back to the future and look at the kinds of skills and organizations that will survive in the age. So I hope this is interesting for you. Certainly, I sit next door to Silicon Valley, 45 minutes south, and I see it happen whenever I visit Silicon Valley and whenever we're doing work in the area. So let me go to, I'm afraid that's not, okay, here we go. So let me point out that the first machine age was the Industrial Revolution. As we know, that muscle power was replaced by steam power. And there were four defining technologies: steam power itself, and then we had electricity, internal combustion, and of course, indoor plumbing and sewage treatment, which changed the ways we lived. So if you had gone back to 1749, you wouldn't have recognized life at that point, because these things happened after that. But what has happened today is that was the first big shift that took place. But what has happened today is what we all know, and that is the knowledge revolution, or what we call the second machine age. And maybe it is beyond machines that we are going to go, but more on that in a moment. So today, the technologies that define what we do are computers and digitization, and of course, telecommunications. So ICT technologies are what are driving us today. So what does this mean in terms of how the world has changed for us? Digitization, the conversion of information, knowledge to zeros and ones, has completely changed the way we deal with information, and especially with how we manage. The second piece that has changed life completely is recombinant innovation. So if you think of the three fundamental forces that are driving our age, the second one is recombinant innovation. An example would be the World Wide Web. The World Wide Web is just a combination of three things. The TCP/IP digital network, or the protocol. It is the addition of HTML, and then in addition to that, it is the piece about having a browser. So those three things combined created the World Wide Web. So if you look at Waze or you look at Google, they're all recombinations. There's nothing really new. But what this has done has made possible exponential change, because these recombinations are driving what is happening today. Finally, and this is the piece I want to dwell, all this has resulted in exponential growth. And I'll show you, I have 150 examples, but I'll show you only 10 of how that exponential growth is taking every part of our lives. We feel it in the speeding up of what we do. And so the impact on the volume, variety, and velocity of change is amazing. So if you look at that little graph below, I'll show you the blown-up version of the graph. When the first machine age took place, that's when we got the first exponential shift, the knee of the curve for the exponential shift in population. And so I'll show you that that's not only true of population, it's true of everything else that has taken place. So we're all familiar with the exponential curve. So the linear, the red dotted or the red squared line is a linear growth. And then the yellow dotted line is exponential growth. So that's growth which, if I put on a logarithmic plot, will be a straight line, but which on a simple numbers plot shows up as that. Now, if you look at all the changes, Moore's law is the first example of this. When Gordon Moore first suggested this in 1972, what happened at that time was that he saw that transistors, he initially said it would be, they'd double every 2 years, but then it was brought down to 18 months. So what you see here is the 5 stages. So it's the 5th stage that we're in, starting with punch cards. When I did my PhD thesis, I had actually punch cards at that time. But if you look after that, if you look at the evolution to today's what AMS does, which is essentially, if you look at what we do in terms of chips, we have seen this exponential growth in the power of computing. So if you look at that, this is the population growth graph. You see that world population remained fairly constant till it hit about 1750. That's sort of the beginning of the Industrial Revolution. And then it gradually ramped up, got to the knee of the curve, and then took off in about the 1850s and 90s. Of course, there's a limit to this, because we as human beings control the amount of kids we have. So as a result, we're going to level off. So this is not exponential forever. But everything else I'm going to show, for example, if you look at the evolution of computer power or cost in terms of MIPS per $1,000, you can see that the last 5 lines on top, as we move every 10 years, that becomes more and more exponential, because our expectation is belied by what actually takes place. So the curve has become sharply exponential. In other words, it's not only exponential in the first round, because that's a logarithmic plot, but what it does is that it shows that there's a second level of exponential growth. So there's an exponent to the exponent, all right? And that has resulted in a change that is extremely fast. If we look again, and we look at the transistors per microprocessor, which you're very familiar with, again on a logarithmic plot, you can see that the upper end of the graph is growing again at exponential of an exponential. So again, we see this change taking place. And I give you examples, the processor performance, for example, in MIPS, millions of instructions per second. You can see as the evolution of the basic chip took place, as you get to the top, it's again increasing at an exponential to an exponential rate. Dynamic RAM price. So if you look at that, the bits per dollar of production, and if you look at that, that is indeed, again, an exponential not this time an exponential of an exponential. If you look at random access memory, if we look at the average transistor price, which if you look works in the other direction, again it's a logarithmic plot, and then magnetic data storage. So I could go on with this story, and I could show you that it's true of GDP. It's true of GDP per capita. But you can see that if you look at the basic doubling or halving of technology times, we go from dynamic RAM memory half-pitch feature size every 5.4 years down to 1.1 years for total bits shipped. So you can see that in all of these cases, we have exponential growth. So point made, where are we headed? And this, if you are aware, is where we are at a point of what you would call superintelligence. So exactly what's going on at JOANNEUM, by the year 2029 in the first prediction, 2069 in the second prediction by Kurzweil, Ray Kurzweil, who lives in Silicon Valley. I'm doing an AI debate next week. I've got the two best guys in AI, Professor Stuart Russell from the University of California, Berkeley, and Professor Jerry Kaplan from Stanford coming and debating superintelligence on our campus. But you can see that in this prediction, if you look at Sequoia, that's going to be around 2029, 2030. And then if you look, that's when a single human intelligence will be exceeded. And if total human intelligence being exceeded is not far behind, it's 2069. Think of that. Machines will exceed the capacity of human beings to handle the world. So we will become like gorillas, all right? Because today, what gorillas are to us is what we will be to the super intelligent machines that will be running the world. And thanks to JOANNEUM Research. So hold Dr. Prebill responsible. Okay, so content, his robotics piece is going to overwhelm us. All right? So if you can see this, I'm jokes aside, this is a serious moment. So the question is, will we be able to control our machines, or will the machines need us once they're super intelligence? Because they'll say, they don't need us, they'll push on. All right? No more is it science fiction. So that point made, you can see that what does this mean for us? So what it means is fundamentally it changes the way we run our corporations. It changes the way we manage. It changes the way we learn. And it changes the way, at least where I am, universities are structured. I believe the university is under radical transformation. All right? I know I have from the Technical University of Graz and Karl Franzen's university here, but I think as the university as we know it is going to fundamentally change, unless it's just a social organization where people get together to have 4 years of fun. So it'll be a club of people who get together just to have fun on a campus, drink a lot of beer, go and see a lot of football, and that's it. All right? So we need to understand what societal changes are taking place in the second machine age. So if you think about the 20th century, it was a push economy. It was an economy where there was predictability, there was hierarchy, it was all about control, it was all about organizational routines, and the minimization of variance. So the S-curves were long, all right? But that is changed in the 21st century. Essentially, what we've got is a pull economy where we've got these S-curves being very short, but rising in an exponential fashion, the right side of the graph. So you can see that the infrastructure is continually driven by the exponential advances of computation, that's digitization, recombinant innovation, and exponential growth. And what that's doing is there's no predictability, there's no hierarchy, there's no control, there are no organizational routines, and variance is increasing. Remember that the organizations that we ran come out of the Second World War. So they come out of military command and control. So in the past, it was all about control. Now it's about managing diversity, variety, and horizontally managing. So if you think about what has happened, the second big shift has happened. So it's an explosive shift. And so this is how business is changing. So if you look at the unicorns, the time for a unicorn to get on board has been falling sharply. So on the x-axis are the number of years, and along the bottom axis are the different kinds of unicorns that have been there. And you can see the time is dropping between becoming unicorns. And not only is it something that is true of the Silicon Valley, even though 52% of as of last year, 52% of the unicorns came from Silicon Valley, but that's changing very fast. You can see that the rest of the United States, especially Europe, with 21%, is, so this is a worldwide movement. Even India and China are in it, all right? So this is changing completely. And then, on top of that, you can see the accelerating rate of change that has taken place. So if you look at the first 50 million users, for radio it took 38 years for 50 million users. For the internet it took 4 years. For Instagram it took 6 months. And for the game Angry Birds it took 35 days. That tells you something, right? So it's telling you that the pace of change is just increasing. As we are digitized and we are connected, things are getting faster. So if you look at the emerging thousand-fold increases, they're in big data, they're in cloud computing, they're in IoT and IIoT. So this is where the change is thousand-fold, taking place all the time. So do you know what is the average time between deployments at Amazon of the software that they put out? Any guess how long it takes for them to introduce the next deployment? You'd guess 2 years, maybe 6 months, maybe 3 months, maybe 1 month? No, it's 11.9 seconds. Okay, 11.6 seconds. Pardon me, I was slower by 0.3 seconds. So you can see that at any time deployment at Amazon, there are the maximum number of deployments in a single hour are 1,079. The mean number of hosts simultaneously receiving a deployment is 10,000. The maximum number is 30,000. So just think of that. We were at AMS yesterday, Dr. Prebel and I asked the gentleman, Dr. Manninger, and I asked him what was the time it took between them to get a new chip design. He said it's down to 6 months that they get a sensor. It's even lower, but they can only do it in about 7 to 8 months. But you think about that and you think of the deployments. When we did a project for AMS in 2000 with our MBA students, at that time they were 120 or 140 million. Dr. Prebel was the CTO at that time. And today they're at 691 million. But the pace of change within AMS has just become what you would call helter-skelter, to an old Rolling Stones song. You know, that's what it is, all right? So you can see that that is the pace of change. So previously we depended on stocks of knowledge, but what has happened today is it is about flows, not stocks, because we're constantly renewing what we're doing in terms of the knowledge flows that we participate in. So we have moved from scalable efficiency, which was the mantra of the 20th century, to scalable learning, which is today the situation. So I want to talk briefly about the 3 talents that still remain away from robotics. And those 3 talents today, which robots and artificial intelligence have not yet been able to overcome, are the 3 very human conditions. But notice that 2 weeks ago, a computer for the first time, defeated a player at Go. For those of you who know, because that's simultaneously, it's the same month that Marvin Minsky died, the same week that Marvin Minsky died, one of the founders of AI. But you can see that that is another inflection point that has taken place. So as yet, ideation, the creation of new ideas and concepts, is a human trait that has not been completely overcome, but is gradually being overcome by machines. Large frame pattern recognition. This actually has been breached quite a bit. So artificial intelligence is now being able to do large-scale pattern recognition, which is based on digital technologies. So we're seeing that even that is being broken. And complex communication, as machine language has improved, that has also been breached. We do have the Turing test, and the Turing test has been exceeded in particular cases. So complex communication has been the result of significant speech. So these are the three remaining bastions where artificial intelligence has not yet been successful. But it's there, it's on the brink. What does this mean in terms of learning? So as a university professor, I dwell on such things. So you can see that learning has changed. It's become lifelong learning, and it's self-organized learning environments. So increasingly, we are using MOOCs as we teach. We are using flipped classrooms as we teach, because that is how, no more do we lecture on a stage. This is unusual, that one stands on a stage and lectures to a group of people. We now come, we do our homework at home, we do our homework in class, and we do our lectures at home, because they're on iTunes, and you watch them, and then you come and you solve problems together. So that's where we are headed. Of course, we've got games and gamification of what we are doing. So Second Life used to be previously, but now it's virtual reality, and that's entering the classroom. I've got a brand new building which has 12 labs. It's a business school building. It has 12 labs and 8 classrooms. So it's kind of flipped because we've got design thinking labs, we've got web design labs, we've got networking labs, we've got all kinds of things. Learning analytics and big data is what's changing even what we do. So if I look at the realities, so coming to the management part, if I look at the realities of what has happened in terms of management, the change that we experience as managers, and I know most of you are technologists who are managers, that has been subject to exponential change. So there's no one model we can depend on for success. We have to constantly experiment at the margin. All of our work has become knowledge-based, so even physical things have become knowledge endowed. So if we think of the IoT, I think there are now 15 billion hosts that are connected, but we will soon have 100 billion hosts that are connected to each other, speaking to each other. So it's all based on knowledge. We have unbundled our organizations. In the United States, 35 to 40% of the workforce is what you would call independent contractors, right? There's a wonderful book by 2 friends of mine called The Naked Job Economy, how they talk about this phenomenon. These are people who work independently of the organizations, but for organizations, and they make a living out of it. And finally, the fact that we are culture impacted, that across organizations, culture is making a big impact on us as different worlds get together to run things. Bangalore and Silicon Valley, for example, or Carinthia and Styria, and then down to Silicon Valley. All right? So if we look at what has changed, so we have moved from a world on the left of predictability, of plans, of hierarchy, of performance, of obedience, of management, of local or global, usually one or the other, but now that's being blurred. So if we think of predictability, that's been replaced by discontinuous change. If we look at plans, it's replaced by options. If we look at hierarchy, it's adhocracy or netocracy, if you want to call it that. Performance has been replaced by possibilities. Obedience has been replaced by engagement or involvement. The millennials are a great example. We have a lot of millennials who come to school. They're very different from us. They think differently, they act differently, they learn differently. Management, it's decentralized federations, as I told you, the 35 to 40% of the workforce in the United States. And we go this difficult word that sticks in my throat, global. It's simultaneously global and local. So that's where we are being led to. So if you think of the key organizational concepts, one is familiar to you from the European Union. It's about subsidiarity. So the decision goes to the level where the action takes place. And that's taking place in our organizations as decisions move out of the organization, but into the organization also. And that they take place in clusters, like the cluster in Styria. Earned authority instead of authority that is given to you because of your position. This authority has to be earned all the time. Why? Because it's not, people don't give it to you. It depends on how you are able to deliver on the things and how you're able to support others in delivering the things. It's about influence without authority very often. It's about virtuality and teams. I have teams all over the world whom we are working with, and therefore I sleep little, but I work with teams all over the world. Our organizations have been de-jobbed, and I mentioned the 35, 40% number. So you're working with people who are not in the organization. And if you look at distributed leadership, you have the leadership that's distributed all across the organization. So the leaders don't come from the top, they come from across the organization. So what is leadership in the 20th century? It's all about integration, resourcing, and orchestration. So I know Babek was mentioned. So you're resourcing and you're orchestrating what happens at JOANNEUM. And that's your job as the Babek head. Ad hoc. It's adhocracy, so it's being entrepreneurial, it's being nimble, it's being networked, it's being part of as many networks as possible. It's being distributed, so initiative self-organization. It's about values being distributed across the organization, and that's the job you do. You build values, and then you move responsibility down to where the work gets done. And so if you look at the organization itself, it's inverted. It's frontline and grassroots. So let me show you an example here. So if you look at the double inverted pyramid, so on the left is the organization we inherited from the Second World War. That was the military command and control organization. Okay, in spite of Theodore Levitt and all the marketing gurus, that was what we had. And if you look on the right, that's where we are today. So on the left, leadership was doing the right thing. It's about vision. And management was doing things right. But today, the two are combined in the same spot. All organizations, all people in those organizations have to be both. So what are the leadership skills for a networked age? And here I take something from John Seely Brown. John and I, excuse me. So what John has been arguing is that we have, if you think about management, think on the left of the steamship era, that was the paradigm till the digital age came along. And then the digital age came along, and we had the yacht, where you sailed in the winds, you tacked correctly, and you caught the winds. But today where we are is in whitewater kayaking. So that's the world we face. Things move so fast that we have to sense as we manage what is going on. So if you think about it, a whitewater kayaker skillfully reads the currents and disturbances in the context around her, interprets the flows from what they reveal about what lies beneath the surface, and leverages the flows for accelerated action. So no more is it about scale for efficiency. It's all about scale for learning, because you have to constantly learn to navigate. You've constantly got to pick up the movement in the water to keep your organization moving forward. So if we think about it, these are the six imperatives that we have. Cross-functional integration, change management, we know that. Cultural fluency and curiosity. That is very much required. That's the number one skill for an entrepreneur. and globally responsible asset and resource management. So if we look at those, Clayton Christensen, along with two of his co-authors, Greg Gergetsen and Jeff Dyer, surveyed 5,000 businesses and came up with the 5 characteristics that characterize successful entrepreneurs and managers. And the 5 characteristics aren't the ones you think. The first one was questioning, the second was experimenting, the third was observing, the fourth was associating, and the fifth was networking. So these are the skills we need as managers in the new age that we are in. All right. So we're moved from hierarchies to what you call netarchies, or they are integrated circuit organizations where all the connections are between ecosystem-type, decentralized ecosystems. We're moved from complicated systems to complex systems, which are densely interconnected and entangled. Ann Pendleton Jr., who is a co-author with John Seeley Brown, said the following: "No significant problem is an island unto itself, where the unintended consequences of an action can often overwhelm the intended consequences." And an Austrian, Friedrich Hayek, said this many years ago in a paper he wrote in 1936 in the Economic Journal. Very interesting. Change and scalable learning is what it's about. So we have to learn how to reframe, regrind our conceptual lenses, and through that, get to scalable learning. That's what we face. Our organizations, we are knocking ourselves silly against them because they refuse to change. And organizations like Facebook or Google or Uber are the ones that are making those changes that allow the kind of managerial leadership that I talked about. So I want to go back to Karl Raimund Popper, another great Austrian who I've read when I was a very young man extensively, Logik der Forschung, if you remember the book. I'm sure all of you read Karl Popper as young people, like I did. But what he said was, think clouds, not clocks. What he said was, to understand a clock, you can take it apart, its individual pieces, and you study the pieces, and then you can understand how a clock works. A cloud, you can't take apart a cloud. A cloud is a dynamic system. A cloud you can only study as a whole. So Karl Popper, the great philosopher, said all problems are either clouds or clocks. One of the problems we have as a culture is we take clouds and pretend they are clocks. That's because we are all engineers, and we think about in engineering terms. So the time has come to get out of the engineering mode, folks, to become biologists. All right? So it is to become an ecosystem manager, a gardener, if you so will. All right? So if you think about it, ecosystem intelligence is what makes today's manager thrive. A mechanical system, a watch, is divisible, while an ecosystem is indivisible. So because ecosystems are indivisible, they are environments where all feeds back into each other as feedback loops. So if you think about how learning takes place, this is an example. We hold a number of these. These are hackathons. Okay, that's where we find the millenniums learn from each other. They learn so much outside the classroom. They connect physics to economics. And they may not learn it. They may be an economics major, but they're connecting physics to economics. And so they learn together. They learn peer-to-peer. So they learn through concentrated diversity, mutual passion, and social action learning. They are already tuned to the future organization. And they are edge dwellers. So you will remember, I go to Thailand often, and in Thailand I see some of these where Buddhist monks face off in debates. And they're actually debates. The gentleman he's going to clap because he just won the argument, he thinks, while the gentleman below is reaching out to say, no, I'm going to counter you. That's how learning has become. It's gone back to its Socratic roots. So I want to end with this. The world of Warcraft. How many of you played Warcraft? Okay, I recommend you play Warcraft because you'll become a better manager. I'll tell you why in a moment, all right? So this is what is called a multiplayer online game, a massively multiplayer online game, a MMOG. And if you think about what they do here, They have these videos, they have wikis, they have databases, blogs, Blizzard forums, and you actually have a guild master. And the guild master has to create a vision and a set of values that attracts members of his team, because then they go and they are going to be participating in the game. He finds, evaluates, and then recruits players that have a set of diverse skills and which fit with your norms, creates a platform from apprenticeships or newbies, orchestrates group strategy and governance, creates, sells, and adheres to the governance principles for the guild, and adjudicates disputes. So these are the fundamentals of leadership, and they learn from the world on Warcraft, right? So it's all about peer-to-peer learning. It's about deep co-mingling of practices, blending intelligence and operations, all right? So it's an amazingly powerful way for amplifying informal learning practices. Michael Polanyi said that most of our knowledge is in tacit knowledge. Friedrich Hayek also then pushed that forward. So Polanyi's insight is today becoming reality through peer-to-peer learning, because that's how knowledge is being transmitted. To end, learning and managing in complexity is what it's about. That everything you do alters the system because of interdependencies, that you cannot learn about a problem without action. So it's action learning. That all problems occur in social contexts that usually overwhelm any technical complexity. So what happens is that learning is applied. It's in a social context. It's all about experimenting. So to end, I'd like to end and say that the big shift has happened. It is for us to now reform our organizations, reform our ways of managing to handle the complexity of exponential change. How we ultimately succeed will depend upon how we avail of the opportunities. And the management problem within the 20 years we have left, if Ray Kurzweil's first prediction is to be believed, is about changing from an engineering perspective to an ecosystem perspective. So with that, I leave you to those thoughts. Thank you for listening, and I'll leave you with a Chinese proverb at the end of it. All right? Thank you very much.